place off Ocean Avenue, where I used to sit and talk with you
about the physics of scuba diving. To begin, let's start with the acronym of SCUBA. Self-contained underwater breathing apparatus. Scuba diving is all about pressure, which is force divided by area. Pressure and area are inversely proportional, so as one goes up, the other goes down. Pressure and force, on the other hand, are directly proportional. The sum of the pressure above sea level is equivalent to 1 atmosphere. Therefore, the more submerged you are in the water, the more pressure you have built above you. Around each 10 meters deeper you get, an additional atmosphere is added to the pressure above you. Now let's talk about Boyle's law, which says for any gas at a constant temperature, the volume of the gas will vary inversely with the pressure. This is Boyle's simple equation, and from simple algebra, you can basically solve for anything you'd like. Our lungs can hold a volume of about 6 liters of air. Let's say you dive from 1 atmosphere to about 2 atmospheres. From Boyle's law, we can see that around 2 atmospheres, our lungs can hold a volume of around 3 liters, which is around 50% of our lungs' capacity at 1 atmosphere. In fact, every atmosphere you descend while submerged in the water, an object becomes increasingly smaller because the pressure builds. For example, at 4 atmospheres, our lungs' volume capacity decreases to around 25%. Now let's talk about Charles's law. Bad grammar. Oopsies. Any gas at a constant pressure, the volume of the gas will vary directly with absolute temperature. Here's the equation. Let's say you descend from sea level to around 3 atmospheres. You have to change Celsius to Kelvin in order for Charles's equation to work. From just the simple calculations, we can see that the second velocity at 3 atmospheres below the sea level is around 5.6 liters. As you dive deeper, there are more atmospheres above you, meaning the pressure increases and the volume inside your lungs decreases. This means the opposite for when you are ascending to the surface. CO2, O2, and N2 are abundant in atmospheric air. Divers also use various mixtures of oxygen, nitrogen, and helium. 60% of our bodies are made up of water. Whenever a gas is in contact with a liquid, a portion of the gas will dissolve in the liquid until equilibrium is reached. So as pressure increases, the total pressure of a breathing gas increases as well, which means more gas dissolves in your body tissue. Let's say you want to escape the jaws of a great white shark. If you ascend too quickly and don't take enough time to re-equalize your pressure, gas bubbles will form, which will enter your body tissue, and thus could cause a stroke. Decompression sickness does not make a happy diver. Everyone must pay attention to the dive tables before entering the water. Although these may seem complex to read, they ensure a diver's safety if followed correctly. In a nutshell, they show the deeper you go, the more gas is dissolved, and thus the less time you have to dive. Follow these tables, and you'll be chillin'. Buoyancy is another main physics principle when it comes to scuba diving. Archimedes' principle states that any object wholly or partly immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. If the weight of the submerged diver is less than the weight of the displaced water, the buoyancy is positive. If the weight of the submerged diver is greater than the weight of the displaced water, the buoyancy is negative. If the weight of the diver is equal to the weight of the displaced water, then the buoyancy is neutral and the diver is suspended. This is what neutral buoyancy looks like in action. Hey, there's me! Diving weights are meant to counteract the buoyancy. As you inflate your buoyancy control device, you increase your amount of volume, and thus you float. If you deflate your buoyancy control device, you have less volume, and then you sink. Divers want a more negative buoyancy to see things on the sea floor and a positive buoyancy to see things near sea level. The equation for Archimedes' principle is as follows. The buoyant force equals gravity times the density, which is mass over volume, times the volume. Seawater has a density around 1,020 kilograms per meter cubed. Consider this density, the gravitational constant, and the volume of the displaced water. From the equation, we can see that the buoyant force is around 14.7 newtons. The last concept I'll cover is light. Water slows the speed at which light travels. As light enters or leaves the water, this change in speed causes light rays to bend or refract. This is why a pencil in a glass of water looks bent. Humans see the colors Roy G. Biv in the electromagnetic spectrum. The color red is less energetic and has a longer wavelength. Blue, on the other hand, is more energetic and has a shorter wavelength. Because of this, as you dive, you will notice that red disappears first and blue disappears last as you descend deeper. And that, my friends, is the physics of scuba diving.